Thank you. Hi, everyone. So I'm here to talk about unifying logs and metrics with Elasticbeat. And I would like to start by asking you a few questions. How many of you are using Elasticsearch? Oh, that's quite many. How many of you are using Elasticbeat to ingest data to Elasticsearch? Okay, that's quite good. Okay, then I will start by saying a few words about myself. So I'm team lead at Elasticbeat. I'm also a software engineer, so I code from time to time. I joined Elastic 1 year ago, and today I will talk to you. So I will start by telling you about the beats. So beats are lightweight shippers that collect and ship all kinds of operational data and send it to Elasticsearch. Let's take one by one. Bits are lightweight shippers. What I mean by that is that they are lightweight applications. They are written in Golang. They are installed as an agent on your server. And they have no runtime dependencies. They collect all kinds of operational data. So we have Filebeat to collect the logs. We have Winlogbeat to collect Windows event logs. We have Topbeat to collect system statistics like CPU usage, disk usage, memory usage, and so on. We have Packetbeat to collect insights from your network traffic. And we are working currently in releasing Metricbeat that collects metrics from external services. After they collect all this data, they ship the data to Elasticsearch. The biggest advantage of using Elasticsearch is that you don't have to anticipate what metrics you'll need in the future. You just push the raw data into Elasticsearch, and then you can create the metrics on the fly when you need them. So the Elastic Stack, it was previously called L-Stack, now it's called Elastic Stack. It contains the ingest side, the Logstash and Beats that are pushing the data, that are collecting the data and pushing the data to Elasticsearch. And then on top of it, you can use Kibana to visualize it. But today, now in my talk, I will talk mostly about the Beats. So Packetbeat is the first bit that we created. It captures insights from the network packets. The way Packetbeat works is by sniffing the network traffic. What sniffing means is that you get a copy of your network packet, and this can be done at the operating system level or hardware level using mirror report functionality of the switches or dedicated tab devices. And Packetbeat is completely passive. This means that you have zero latency overhead. And if the application that is monitoring your network dies, then your infrastructure is not affected. Packetbeat is not the first open source tool that is using sniffing. Wireshark and TCP dump are the most well-known ones. And also there are other intrusion detection systems like Snort that use wire data. And they are used especially in the security domain for troubleshooting network issues, for troubleshooting applications that are using standard protocols, and for performance analytics. Yeah, let's see how you will do if you want to monitor your servers in your network using open source tools. So an option will be to SSH to each of these servers, then start a trace using TCP dump, and then collect all these traces from all the servers to a common place, then merge all these traces together into one trace, and only then you can visualize it with Wireshark. In case you have, in case you have quite many servers, this might be a challenge, right? So this is a problem that Packetbeat solves. In Packetbeat, you are able to visualize your network packets, your traffic using in real time. So the way Packetbeat works is by capturing the network traffic, decoding the network packet, then correlates the request to the response into transactions, then extracts measurements, and then sends them to Elasticsearch. So we have quite many available decoders in Packetbeat. HTTP, MySQL, PostgreSQL, Redis, DriftRPC, Memcache, and also from the community are MongoDB, ICMP, DNS, MQP, NFS, and also you can add here your own decoder. In the configuration file of Packetbeat, you just need to specify what interface to sniff. Here in this example is any device, but this works only on Linux. And also for each protocol, you have to specify on each port to listen for the traffic. After you start Packetbeat, then it will start sending the data to Elasticsearch, and only then you can visualize the data of Kibana. Here is an example of a dashboard that is using data, that is visualizing the data that are coming from Packetbeat. We are offering a set of sample dashboards that you can use as a starting point for your customized dashboards. Let's zoom in to each of these widgets. So here you see the map. This is the client location map. And you can see here that most of the HTTP requests are coming from Berlin, actually because this is it's a traffic that is generated from Berlin. Another widget that you will see are web transactions, database transactions, response time, repartition over time, and percentage. Another interesting widget that you can have is latency histogram, and also the errors for MySQL and HTTP transactions. And here you can see, maybe you can't see, but here you can see that there is a pike. So the number of HTTP transactions and the number of MySQL transactions, it's a bit higher than usual. So if we want to just see what's happening in this period of time, we can just select this area, and then we'll be able to see details about the transactions that are in that specific time frame. And also you can see in Kibana, the time frame is also changed. Another nice thing that you can do in Kibana is that you can have these top processes, top HTTP queries, sorry. And so you can see here, for example, you can see how many get HTTP queries of this type there were, and the number of them, and so on. In the Discovery tab of Kibana, you'll be able to see all the transactions that are collected by Packetbeat. And if you click on one of them, then you'll be able to see more details about it. So here, for example, there is a MySQL transaction, and you can see the type, the method of the MySQL transaction. It was a select. You can see if it was an error or not. You can see how many fields are returned and how many rows are returned. In case there was a HTTP transaction, then you can see if it was you can see the response code, you can see the content length of a response and things like this. And what is important, or what's important to note, is that also you can see this client location that is calculated based on the client IP that can be used to show you the map that we've seen earlier with the client location map. Packetbeat is also able to show you the flows, not only the transaction. And this is useful in case Packetbeat doesn't have support for a certain protocol or is using TLS. And what this means is that it gets data from about IP, TCP, UDP layers, and data like the number of packets, retransmissions, inter-arrival time. And for using flows, you just need to configure the flow section in the configuration file. Under the discovery on the discovery tab of Kibana, you'll be able to see all the flows in real time that are flowing in your network. And if we select on one of the flow, you could see more details about it. Here, for example, we can see for each direction, so because the flow has both two directions, right? We can see for each direction a couple of statistics, like the number of bytes or the number of packets and so on. So a monitoring solution won't be complete without having together the logs. So we have Filebeat, that is a simple log forwarder that sends all the log lines to Elasticsearch. It's a successor of Logstash forwarder that was written by Jordan Cecil, the creator of Logstash. And it was kind of popular, so there are quite many users that are still using Logstash forwarder. But the Logstash team didn't find the time to maintain this project. So we decided to take the code from Logstash forwarder, do some improvement, and release it at Filebeat. So if you are using Logstash forwarder and you want to upgrade to Filebeat, it might be interesting for you to look at the migration guide that we have in our documentation. Filebeat keeps the same guarantees as Logstash forwarder, never loses a log line, and this can be done because Filebeat is reading the log files line by line and remembers how far it read. Filebeat sends the log lines as they are without parsing them. So who is doing the parsing then? So there are actually two options. One option is to use Logstash. So in this scenario, you will see that Filebeat is sending the logs unparsed to Logstash. And Logstash is using filters like grok, GeoIP, mutate to parse the logs. And then sends the parsed logs to Elasticsearch or to other systems. And it's nice because in Logstash, the filters are quite flexible in the sense that you can group them by conditionals, and you can also create your own custom filters in Ruby. Another option is to use the ingest node plugin of Elasticsearch that is available starting with 5.0 Alpha 1. And in this scenario, Filebeat is sending the unparsed logs directly to Elasticsearch. And you have to configure via REST API processors and filters like GeoIP, mutate, and grok, similar with the ones that you have in Logstash. This scenario is easier in the sense that there are less moving parts. Now let's have a look to the configuration file of Filebeat. So in Filebeat, you just have to configure a list of prospectors that fetch the data. So for each prospector, you define an input type, if it was a log or if there is standard in as an input, and also a list of paths from where to get the logs. And in addition, you have to also specify the encoding, and by default is plain. After Filebeat is starting sending the data to Elasticsearch, you will be able to see in Kibana all the log lines in the discovery page. And if I click on one of them, then I'm able to see more details about the log line. For example, here in the message, you will be able to see exactly the log line. And of course, this is a sample log line, and in reality, the log lines look more complicated than in this example. For example, in Java, it's common to have exceptions on multiple lines, and the default behavior won't work. So for this, we have the multi-line functionality that gathers multiple log lines together into one line. And you can group them together by using a regular expression. Here you can define under the pattern the regular expression. Yeah. And here is an example of a multi-line. So here you will be able to see, so if multi-line is configured, then the log line will include the whole Java exception. Now, it's more and more common for applications to use structured logging. What this means is that your application logs are written in a JSON format. And of course, there are quite many advantages, right? Because you don't have to choose what data to include in your log line. You can just dump the entire structure. And that's quite nice. And another thing is that you don't have to parse your logs because they are already parsed. And so I would like to show you an example here. So you will see that the log line, I mean the event that you see in Kibana also includes the JSON object. Yeah, and here you can see it better. So your application is dumping a lot of log lines, and maybe you are not interested to index all of those log lines in Elasticsearch. So for this, we have basic filtering. So you can drop the log lines that you are not interested in. For example, you can say that I want to index only the warnings or errors in Elasticsearch, and I'm not interested in the debug messages. And also you can specify what files to drop. After we released Filebeat, we got quite many requests to add the functionality to gather Windows event logs. So for this, we created Winlogbeat. So Winlogbeat has the similar idea with Filebeat in the sense that sends the Windows event logs unparsed to Elasticsearch. So you need to have, you need to use Logstash, either Logstash or Ingest to parse them. It keeps the same guarantees as Filebeat, never loses a log line. And the configuration file is quite rather simple. You just need to specify what event logs you are interested in. And here you can see an example of a dashboard that's, for example, here you can see the evolution of the event logs. And over time, you can also see how many information or how many warning levels there were, and so on. Another simple bit that we created, but rather powerful, is Topbeat. Topbeat collects system statistics metrics. So the idea behind Topbeat is very simple. It's like the Unix stop command, but instead of printing out on the screen all the statistics, it sends them periodically to Elasticsearch. And it's different in the sense that it works also on Windows. So it collects system-wide statistics like system load, total CPU usage, swap and memory usage, per process statistics like the state of the process, the name, the command line that was used to start the process, the PID, the CPU, and the memory usage. Also gathers disk usage statistics like the available disk, used free space, and mounting points. In the configuration file of Topbeat, you just have to specify how often to send the system statistics and what processes you want to monitor. And in addition, you have to specify what kind of data you are interested in. Here is an example of a dashboard that shows you the data that is collected from Topbeat. And for example, if you if you configure different Topbeats to send the data to the same Elasticsearch, then you'll be able to see in one place statistics from different servers. So here, for example, I have 3 servers, and I can see also a few details about each of them. And if you can also see the system load statistics. For example, here are 2 servers, and we can compare one of each other. Also, memory usage statistics. Memory usage graph and CPU usage, disk usage. And this one is my favorite because it looks similar with what the top command prints out on the screen. So you can see what processes consume most of the CPU usage. Consume most of the CPU. So the first one will be the one that consumes most of the CPU. So in this case, it's 300%. And also you can see, you can build graphs based on the data that you collected per process, then is memory usage, CPU usage, and so on. So we collect all this information about system statistics, but we wanted to extend more the type of metrics that we collect. So we decided to start working on a Metricbeat that collects different type of metrics from different systems. So how Metricbeat works is by it interrogates periodically external systems, gets some metrics, correlates them together into documents, and then pushes them to Elasticsearch. So Metricbeat is pluggable in the sense that you can add modules to it. So we created so far an Apache module, a MySQL module, a Redis module, and a system module. And here we are happy to receive contributions from you with more modules for Metricbeat. Sorry. Also, it's important to note that Metricbeat can be also used as a library. So what this means that you can create your own beat that make use of Metricbeat as an infrastructure. And for this, we created an example beat that has one module and uses Metricbeat as a library. And in addition, can also make use of the other built-in modules from Metricbeat. So let's see the difference between a Metricbeat module and a standalone beat. So the Metricbeat modules are available under Elasticbeat GitHub repository, while the standalone beats are available in their own repository. The Metricbeat modules are officially supported by Elastic, while the standalone beats are supported by the community. And the standalone beats, they have their own maintainers, their own users, and their own release cycle. So I show you quite many beats that we created to gather all kinds of operational data. But what we did actually, it was more than that. We created a platform to make it easier to build custom beats on top of it. So we created the Libbeat, and on top of it, you can easily build new beats. Just a few words a bit about this library. Libbeat is written in Go, in Golang, and provides common functionality for all the beats. Like, for example, it provides common functionality for handling the configuration files, for handling command line arguments, for logging, and also make sure that reliably sends out the data. So far, I show you that all the beats are sending data to Logstash or to Elasticsearch, but it can also send data to Kafka or Redis. Based on the Libbeat library, many community beats were created. So what are community bits? So they are standalone projects. They are written in Golang, and because they are using this Libbeat, then they can only concentrate on collecting the data and let Libbeat worry about how to send the data. And they are trying usually to solve a specific use case. Yeah, let's see the difference between an official bit and a community bit. So an official bit is the one that lies in the Elasticsearch GitHub repository. It's officially supported, while the community bits are in their own repository and have their own maintainers, users, and their release cycle. So far, almost 20 community bits were created, and I'm really surprised to see that because we released Libbeat a few months ago. And actually, this slide is kind of old. I created it like 2 days ago, and there were other community bits that were created in the meantime, and unfortunately, I couldn't fit those on the slide. So I have to make 2 slides next time. So let me highlight a few of the bits that the community created. One of them is PingBit. What PingBit does is sends periodically ICMP pings and to a list of hosts, and then records the round trip time. And you can also send the pings over UDP. You can also resolve DNS and so on. Another interesting bit that I would like to show you is execbit. What execbit does is running a periodical command and then sends the standard out and the standard error to Elasticsearch. And I think this bit is kind of valuable in the sense that imagine you can write your application in the programming language that you want, for example, Perl, Bash, or whatever, and then you can index data to Elasticsearch. Another interesting bit that I would like to show you is Dockerbit. Dockerbit that is used for Docker monitoring. It's using the Docker API to export per container statistics like the CPU, memory, disk, network, I/O access, logs, and so on. And another interesting bit is Nagios checkbit that executes periodically Nagios plugins and sends alerts, warning, or critical to Elasticsearch, and also sends some performance data to Elasticsearch. And here is how the events are generated. So we are always encouraging our users to build new bits to solve a use case in an area where they are working on. Because I believe that those people can do a better job building the bit than us because they are the expert in that area. So we are always happy to help you with creating a new bit. And for that, we made it even easier to build a bit. So we created this bit generator that generates a boilercode plate for you. It's using cookie cutter, and you just need to pass a few arguments like the name of the project and the GitHub account and your full name, and then yeah, the bit will be there. In addition to this, we are also offering a way, or we are helping you to build the packages for your own bit. So for this, we are offering the same tools that we are using to build the official bits, and they can also be executed from Travis. So we collected all this data with the bits. We collected different data, right? Metrics, logs, transactions, system statistics, flows, and so on. And our goal is to visualize this data with a single UI with Kibana. So for example, if I want to monitor MySQL, then I'll be able to get MySQL statistics from the MySQL module of Metricbeat, logs like the slow queries from Filebeat, and also the queries from Packetbeat. For example, if I want to monitor the web server, and imagine a web server contains some MySQL in an Apache. It's just an example, right? I will be able to get the statistics about MySQL and Apache from Metricbeat. I'll be able to get the slow queries and Apache logs from Filebeat. And from Packetbeat, I'll be able to get the transactions, the HTTP transaction and the MySQL transactions. And I'll be able to visualize them with a single view. That was everything. Thank you for listening. If you want to hear more about Logstash, don't miss the ingest logs with style by Pere tomorrow in the same room at 12. Now I think we have a few minutes for questions. Thank you.
So, any questions?
Hello. You're now adding a lot of possibilities to add performance data into Kibana. Are you also planning to extend the possibilities to inspect these data, like you have with Grafana or Graphite, that you can?
Yeah. So the question is, if we, I will tell a bit shorter the question, make it shorter. So if we are planning to extend Kibana to visualize easier the metrics, right? This was the question. Yes, we are planning that, but we don't have any official story around it. But yes, definitely.
Any more questions? So one question from my side, can timeline be used as visualization part for those metrics?
Yes, this was an option that we were thinking about, and we realized that timeline is a bit more difficult at the moment, as it is right now, to be used for visualizing the metrics. So we are planning to do another visualization app in Kibana to be meant for the metrics.
Okay, thank
so
you.
I hope I answered your question.
Any more questions? Yeah.
So the question is, what about impact on performance on the machines? For example, if I have multiple beats for log files and top beats and so, and want to have a really short interval, for example, 1 second or whatever, or I have a high load on the system or big log files, trace files that are written. So what is the impact if I use these beats on the machine? So is it high or is it low, or are the metrics grabbed direct from kernel?
So here there are two questions. So one is related to the logs, right? You are referring about Filebeat, right? Especially, or in general? In general. So there is. So this basically, how we call it, they are lightweight shippers. So this means that they don't consume a lot of CPU and memory because they don't interfere with your applications that are running on your machine. For example, if your application is writing a lot of log files and you are not interested about all the log files, then you can filter to get only the log files that you are interested in. And then, of course, you are reducing the amount of data that you are indexing in Elasticsearch. So I would say it depends. It depends how many logs you have. But in general, we didn't have problems with with the bits consuming more CPU and so. So you are always can find a balance, right? I mean, that's.
Yeah, just a little short questions. In case of, for example, of a network failure, how would the Beats clients or the agents react? Would they queue all the collected information, statistics, and so on, and then, as soon as the network connection is established again, will push the data, or will be there collecting and fire and forget?
Yeah, so it depends on the beats. For example, Filebeat has this never loses a log line. So this means that the network is busy, then it stops. It doesn't do anything. And in case of and it tries later. In case of Packetbeat, it drops the packets.
Do we have any more questions?
So to enhance a bit your question, so the way how it works, Filebeat, so for each log line that is sent out, it waits for an ACK from Logstash. And in case the ACK was not received, then it's trying to retransmit the message.
Regarding Packetbeat, if it runs on a central component, let's say a firewall, you have very huge amounts of traffic. How does the Packetbeat impact on the network traffic in itself? So you don't see your Packetbeat packet in your Packetbeat packet and so on.
Yeah, that's an interesting question. I mean, yeah, I don't know. I don't know what to answer to this one, actually. I mean, if you have a firewall, you cannot see the network traffic, so. Maybe I didn't understand the question.
Okay. Maybe I wasn't clear enough. Firewalls do see a lot of network traffic, and it's a perfect place to see what's really on your network.
Okay.
So Packetbeat will create a huge amount of packets itself. So what's the performance of Packetbeat? Let's say if you have a gig of traffic coming through your firewall, how much traffic will Packetbeat itself generate on this?
You mean how much? So you mean by how much traffic Packetbeat generates? You mean by how much data Packetbeat exports to Elasticsearch, right?
Yes.
I mean, yeah, it depends on the amount of traffic that you have. But as I said earlier, you can, if there is a problem in the amount of data that Packetbeat exports, you can also use the filtering to reduce the number of data that Packetbeat exports. But so we did some performance tests a while ago, and the results were not officially, of course, and the results are like Packetbeat was consuming 5% of the whole box. So just to give you an idea, it's very lightweight, cheaper. Yeah.
Okay, more questions. Here.
Just in addition to the first question he had, is it like possible to add to configure an interval in which, if you don't need real-time monitoring, in which the data is being sent to your Logstash server, so that you don't produce packet traffic all the time, but you can like summarize them on your client and then just send it every 5 minutes, for example, if you don't need real-time?
Yeah, I understand your question. So you can, for some bits, for example, for Topbeat, you can configure the period of time, how often to send the data. For the others, no. For Packetbeat and Filebeat, no, because they are meant to be for seeing your traffic in real time. So, for example, Packetbeat sends out the transactions. So I don't imagine how you will combine them together. For example, what we are using right now, so in Elasticsearch you can use the bulk API of Elasticsearch and insert multiple documents in batches. Maybe this is something that you are asking about, but I don't know. In Packetbeat, for example, I don't see right now. I don't know how you will be able to combine multiple transactions into one transaction and send. Yeah, I mean, it depends on the bit, right? For some bits, for example, for metrics, this is something that you can do, and also for Topbeat. So for metrics in general, you can combine, let's say you have 5 minutes of metrics, and you can combine them together and send them once every 5 minutes. This you can do, but yeah. So it depends on the. So yeah, I hope I answer your question.
Yeah.
Also, just a small question: has Beats or based on that, the Elasticsearch then an option for all those metrics data to have some kind of retention, like in Graphite, that you can just, I would say, not have all the real-time data in the dump, but then after some time, some data alter out?
Yeah, we don't have it for the moment, but I think it's a really great feature. Thank you.
How does Filebeat integrate with log file rotation?
Yeah, so Filebeat is doing log file rotation. I don't know exactly what you mean by that. So it's doing log file rotation. You mean so we had some problems regarding this log file rotation? Maybe this is, maybe you can enhance a bit.
Well, typically I don't want a single log file to contain all the history. I would rotate it, say, once a day or once a week or once a month, depends on the volume. And what if Filebeat is watching this log file, how does it switch on to the next segment, or how does it handle how does it cope with the rotation so that it will read the next log file if I switched it, if the file was just switched and rotated?
I'm not 100% sure about this because I didn't code myself this part, but we are supporting, from what I know, log file rotation. I know that there was a difficult, a challenging feature to implement. So unfortunately, I cannot give you more details about that. But just to be clear, so Filebeat is not doing any change on the box. Filebeat is just reading the log lines.
Is there any chance we see a Puppet module for it? Like
there is already a Puppet module.
An official one or a community-based one?
There is a community one, yes.
Okay, is there any plan to go the next level, like for Elasticsearch or Logstash, for Puppet modules?
Yes, actually we are planning that for a long time, but unfortunately we didn't manage to complete the task. But we are planning that. I don't know exactly when it will be ready. Yeah, but there is a community one already in the Puppet module.
Okay, so one last one. Anyone? No more questions? Okay, Monica, thank you very much for a great talk.
Thank you.
Thanks for being here.